Today we are going to look at central tendencies again. However, this time we're going to have some additional data that we can consider sometimes an outlier. And so we'll see that on some of the problems. But first, let's take a look at number one. It talks about that we're supposed to use this table to the right for the first two problems. And it says in number one that the table shows some years in which the Super Bowl is won by the most points. Find the mean, median, and mode. So let's talk about the mean first. We talked about yesterday how the mean represents the average. It equals the average. It's another word for mean. And the average is found by when we go ahead and sum the numbers. So sum all numbers in the data set. And sum just means you're going to end up adding all those numbers. And then we divide. So the line here represents, divide by the number of numbers. So you just count up how many values there are. So we go ahead and add these numbers up. We've got 25 plus 21 plus 22 plus 23 plus 27. And then we're dividing by how many numbers there are. When I count them up, there's 5 numbers. So when we add up all these numbers, we end up with 118. And we're dividing by 5. And when we do that division, we end up with 23 and 6/10 is our answer. And so when we go ahead and write our answer, we can just leave it like that. Remember, sometimes the number is a whole number, sometimes it's a decimal, and all this means is the average, the one that's in the middle when we go ahead and add up all the numbers and divide by the number of numbers, is closer to 24, but it's somewhere in between 23 and 24, but just a little closer to 24. So there it is, 23 and 6/10. Well, that's the average for that data set. We're also supposed to find the median, and when we're finding the median, remember you order the numbers from smallest to biggest first. So look at the numbers here and make sure you mark them so you know you've used them already, so you don't end up using them again. So I've used 22. Now I use 23. And then the next one's going to be 25. And then 27. And so what we do is from there we work our way into the middle to find that middle number. And there it is. Sometimes the median is a number in the data set. So whenever you have an odd number of numbers, the number in the middle will be there. That is the median. If you have an even number of numbers, then you have to find the average between those two. So anyhow, here it is. 23 is our median. Well, from there, we're going to find the mode. So remember what we talked about yesterday. The mode is the most frequent. Well, sometimes we have a number that occurs more than once. Sometimes we don't. Yesterday, we had some modes that we had 2 modes. We had something that was bimodal, so that's when the numbers that were occurring the most occurred the same number of times. Here we look at these numbers and we don't see one that repeats. Well, when no numbers repeat, that means we have no mode. So that's the answer in this case. If we had a number that repeated, let's say this 27 was a 23 instead, then 23 would be the mode. But in this case, there's no mode. Well, number 2, we use that same data set, but we read further, and it says that in 1990, the Super Bowl had the largest winning margin, which was 45 points. Add this number to the data in the table and find the mean, median, mode again. So now we have one extra bit of data. So let's do that. Let's find the mean. So the mean is just when we add up all the numbers. So let's add them up again. 25, 21, 22, 23, 27. So we're adding up all those numbers, but we're also adding in 45. So there's a quicker way to do this problem. If I were doing it, I'm showing all the steps for it, but if you were doing it, you might just add 118 plus 45, and that would give you the answer a little faster. And so actually we could do that. This all makes 118 plus 45. We'll come up with that number in just a moment. But let's put the 6 on the denominator. Remember, there's one extra number there, so that's why it's 6 on the bottom of the fraction this time. So anyhow, 118 plus 45 gives me 163. 163 over 6. And so I do that division, and I end up with 27 and 1.16 repeating. So that's what it ends up being. So that's our mean this time. So there's our mean. And now we want to find the median. So the median is, again, when you take all the numbers, line them up, and you figure out which is the middle. So we'll just rewrite what we've got. We got 21, 22, 23, 25, 27, and then 45 is the last one. And we work our way into the middle. So I'll just put some marks showing that I'm getting there. And here it is. It's in between these two numbers. So the middle number. Now you might be able to figure out exactly what it is. But let's say the numbers were far apart. What you would end up doing is adding the two numbers and dividing by 2. So it's kind of like finding the average of these two, and that's basically what it is. And so if we add those two numbers, we get 48. 48 divided by 2 makes 24. So that's the number right in between. That kind of makes sense. So 24 is the median. And we look for that mode. Oops, there we go. But do we have a number that repeats? Still don't have a number that repeats. So there's no mode. So the mode, in this case, there is none. And the reason is we have no repeating numbers. Well, they ask us one other question here. Which best describes the data? Well, typically the mean is the best description of the data. However, for instance, let's take a look at number 1 here. See that there's a little bit of a difference between these numbers. And the reason why the mean's a little bit bigger is because we have to add these numbers. 25 and 27 are 2 away. 25 is 2 away from 23. 27's 4 away. Well, you look at these two numbers, they're just 1 away. 22's 1 away, 21's 1 away. So that's why the mean's a little bit bigger to compensate for those bigger numbers like 25 and 27. Wherein the median is just exactly the middle number, 23. Both of them are good numbers, but if I was to pick which one's the best for number 1, I would use the mean because it compensates for those larger numbers of 25 and 27. Well, when I look at this one, here we have an outlier. The outlier in this case is 45. It's an outlier because it's way bigger than these other numbers. These other numbers are just in the 20s. They're all in the 20s. But this 45 passes the 20s, passes the 30s, and is all the way at 45. So that one we consider far away from the data or an outlier. And so when we look at these central tendencies, the mean always compensates for all the numbers. That's why the mean went up, because 45 was so much bigger. So when we have an outlier of 45, don't use the mean. Typically you would, but in this case let's not use that. So then you'd go with either the median or the mode. But we have no mode, so we've got to go with the median. And the median's not too bad. See, 24 is pretty close to these numbers, and it's not as close as 23 is. I think if it were me, I would just cross off that outlier and not use it, and just go with the ones that were in the 20s, kind of like what they did with number 1 here. But the outlier shows you how it really affects the mean. So in this case, I would say the best description, so we'll say the best description is the median. And again, sometimes what they'll end up doing is, if you do have an outlier, they'll cross off the outlier and just look at the numbers without the outlier to find the mean, and then they'd use that one. Or if we do use the outlier in the data set, then the mean is the least likely one to be picked as a good representation of the data set. So those are the first 2 problems. There'll be a few more problems in part 2, which go over problems similar to what you'll see on tonight's homework.